everybody, I'm back for part 2. So this one is going into the next sort of piece that a lot of you were asking about, because I had put out there if there were any specifics that you guys wanted to see, and several of you mentioned a few different things, plus we talked about it in the meet the other day. So I'm going to start with the one steps, but we're going to also look at the integers, because I know that was one thing that was mentioned. We'll also look at the fractions and we'll build from there. Okay, so first things first, just a reminder, SAMDEB applies when you're solving for variables because you're working backwards to try and find what the value of the variable is. And so the key is you also have to do the same thing to both sides. So do to one side, the same thing to the other. And remember, your opposite operations would be adding and subtracting, multiplying and dividing, and squaring and square rooting, which we had done back in Pythagorean theorem at the very beginning of the year. I'll deal with that probably in the third video that I do where it's a little more advanced. For right now, we're going to deal with adding, subtracting, multiplying, and dividing. So, looking at this, I only have to do one thing to solve for the variable. And if I have 6 plus x equals 15, in the last video, I showed you there was one way you could do it without having to really do a lot of work out, but just thinking about what's happening. And for those of you that can intuitively think of things, this might be a strategy that helps you. So I would look at this and I would cover up the term that has the variable. And I would say, what do I have to add to 6 to get 15? And in my mind, I know my number facts, and so I know that I would be adding 9. So I know that that x should come out to 9. Showing it the algebra way, the solving, what you're going to do is you're going to take that term that is added onto the x and you're going to move it by canceling it and doing this to this side what you're going to do over here. So to cancel adding 6, I'm going to subtract 6. And again, I have to remember subtracting 6 is what's going to happen over here. Because some people fall into the trap, they, for some reason, think because they moved it over here, they've got to change it to adding 6, but no. If it's a subtract 6 here, it's a subtract 6 here. These are going to cancel out because 6 subtract 6 is really 0. And I don't need to write down 0 plus x. That's redundant and you don't need it. So what's left is a positive x, and here I'm left with 9. So that was what we had said based on the cover-up method. And so if we go back and check our work, 6 plus 9 equals 15. So that is correct. Here, I threw in a little negative sign, just to make it a little extra special. So looking at this, I need to cancel this. And I can think of it as a negative 3, or I can think of it as subtract 3. But the main thing is, I've got to change the sign on it. And I've got to do it over here. So I could have either looked at that as, because that's a negative 3, I need to add a positive 3 to it. Or I can look at it as it's subtract 3 and I need to add 3. But again, whatever I did here, I've got to do over here. So these are going to cancel out. Now, if you encounter a problem where it doesn't cancel out, so say you'd made a boo-boo and you put that down as negative 3 subtract 3, that would actually equal subtract 6 or negative 6. So you know that you didn't get rid of it, so you did something wrong. So you want to be conscious of those things and just think to yourself, okay, that doesn't make sense. What did I do? So if I do that, I'm left with y. This becomes 10. Now, again, I stop and I can go back to the first and I can say, what did I have to add to negative 3 to get a positive 7? And the answer is a positive 10. Okay, so those are two examples of one-step problems. Here's one here. So what would I have to take 9 away from to get a 3? And the answer is 12. So to solve for it, I have to cancel subtract 9 by adding 9 to both sides. And I'm left with those canceled out, and x equals the 12 that I said. So again, 12 subtract 9 equals 3, so I did it correctly. This one, I threw in that negative sign on the other side just to make it a little more challenging. So here, I'm still canceling subtract 9 by adding 9, and I've still got to add 9 over here. Those cancel out, I'm left with x. But here's where your rules about integers come in. And this is where I'm really hoping my classes have their student interactive notebooks at home. Because if you do, you should have foldables from the beginning of the year that we did on adding, subtracting integers. So I'm strongly suggesting using those to go back and review if you're having a hard time with the integers. That was why we made those lovely devices. I didn't just want to kill all the trees. Anyhow, looking at this, if I have a negative 3 and I add 9, I'm actually going to end up with a positive 6. Because it's like saying I've got 3 degrees of cold and I add 9 degrees of heat. So all of a sudden I'm warming things up and I've gone past the freezing mark, so I'm into the positive zone. So these are examples of adding, subtracting one steps. I'm just going to erase these. And we're going to look at some that involve multiplying and dividing. So if I have x divided by 6 equals, let's see, 24. So if I have that, I'm looking at this and I'm saying x divided by 6 equals 24. So again, I can look at this from the cover-up method. What did I have to divide by 6 to get 24? Or I can look at it as I need to cancel dividing by 6. And the opposite of dividing by 6 is multiplying by 6. So I'm going to write multiplying by 6 here. And notice I'm using the brackets instead of that little multiply sign, because in algebra it gets really confusing really fast because x and multiplying look the same. So these are going to cancel out because really, again, 6 divided by 6 is 1. And I don't need to write 1x. So then I'm going to multiply this out and I'm going to end up with 144. Okay? So that's if I've got to cancel division. Now if I have a question like 3y equals 24, then I'm looking at, this is 3 multiplied by y equals 24. I need to cancel multiplying by 3. So what I'm going to do is I'm going to divide by 3. And I'm going to divide by 3 over here. Those are going to cancel out. Again, I'm left with my variable. And then that is going to give me a positive 8. Okay? So notice in both cases, the opposites were multiplying and dividing. Now, again, that positive negative rule system that we had, some of you have forgotten it. So we're going to go over that. So if I have negative 2x equals 12, I need to cancel that multiplying by negative 2, because that negative's got to stay with the 2. So I'm going to divide by negative 2 on both sides. Those cancel out. I'm left with the x. But now I've got to stop and look at this, and I've got to remember, if I'm multiplying or dividing different signs, so a positive and a negative, I'm going to end up with a negative answer. If they were both positives like here, they end up positive. Or if they're both negatives, I end up with a positive. Because if they're the same sign, I end up positive. If they're different signs, they end up negative. So this ends up being negative 6. So just keep that in mind. Same signs, you end up with a positive. Different signs, you end up with a negative. So for instance, if I had negative 3x equals negative 36, I need to cancel that multiplied by negative 3 on both sides. And I'm left with x. And this, because they're the same signs, I'm going to end up with a positive, and I'm going to end up with 12. Okay? If you need to, this might be a moment where you might want to pause it and you might want to practice a couple problems like this just to make sure this makes sense. So that was looking at one-step problems, and that's looking at using the integers. So I'm going to erase. And I'm going to look at two-step problems. So two-step problems are where you've got a couple different things you've got to do. And that's where SAMDEB really comes in. So for instance, if I have 2x plus 5 equals negative 7, I've got two terms here that I've got to deal with. And I've got two operations I've got to deal with, because I have multiplying and I have adding. So in this case, once you figure out what your operations are, you're going to look at SAMDEB, which tells you adding and subtracting have to be dealt with first. The other thing, when it's more than a two-step problem, is you might be able to combine things together. There's no like terms on the same side that can be combined right now. So the first thing we've got to do is we've got to cancel that add 5. So the opposite of adding 5 is subtracting 5. And again, I've got to do it to both sides. These cancel out. I'm left with my 2x. And this becomes negative 12 because it's 7 degrees of cold and I'm taking away heat. So I'm getting colder. Now I'm left with 2 multiplied by x. So I need to divide in order to solve for x. So I divide by 2 on both sides. I'm left with negative 6. And that's my final answer. Now again, final thing you should do is go back and test, does that work here? So 2 times a negative 6 would give me a negative 12. Negative 12 plus a 5 would give me negative 7. So I know that worked out. Sometimes you're going to see problems where it seems like it's written backwards for you. So 18 equals negative 4x plus 2. So again, I'm looking at this. Some people might be concerned because all of a sudden the variable is on the right-hand side and there's only one term on the left. The beauty of an equation is, if you want to, you could actually flip that over and you could make it into negative 4x plus 2 equals 18, like that. Now, you don't have to do that in order to work this out. The key is you just have to remember, again, what you do to one side, you've got to do to the other. So looking at this, I have a multiply by a negative 4, and I have an add 2. So the first thing I've got to look at is, I've got subtracting and adding, so I've got to deal with that first. So I've got to remember to take away 2 to cancel those out. And again, if I did take away 2, I've got to do take away 2 over here, and I end up with 16. And then I'm going to have to divide by negative 4 on both sides. And I'm left with negative 4 for my x. Okay? So the thing is, I canceled the plus 2 by subtracting 2 on both sides. Once I simplified there, I was left with 16 equals negative 4x. Then, because it's negative 4 multiplied by x, I know that I've got to divide by negative 4 on both sides, and I'm left with 16 divided by -4. They're different signs, so it becomes a -4 answer. Again, I can test this out because -4 times -4 would be +16, and +16 plus 2 gives me 18. I'm going to erase that one. And again, if you're thinking you've got questions, sometimes pausing the video and coming back to it makes sense. So here's one that I know several people were asking about, because they were asking, what do we do when there's dividing in the middle of it? So for instance here, I have C divided by 40 plus 6 equals 26. So again, using SAMDEB, I've got to deal with that adding or subtracting, in this case adding. So I've got to move that over here first. So I've got C divided by 40 plus 6, but I've got to subtract 6 from both sides. That cancels. You know what? To make my own back better, I'm going to move that over there. So here, I'm left with C divided by 40. 26 subtract 6 is going to leave me with 20. Here, I'm going to look at, okay, if I've got something divided by 40, I've got to cancel dividing by 40 by multiplying by 40, and I've got to do it to both sides. So, multiplying by 40 here, those are going to cancel out. I'm left with my variable, and this is going to end up being 800. Okay, so again, 800 divided by 40 is going to give me 20, and that added to 6 is going to give me 26. Now, you might say, okay, what about this cover-up method that Mrs. Popowich was talking about a few minutes ago? Well, again, what do I have to add to 6 to get 26? The answer is 20. So then I know C divided by 40 equals 20. So then what do I have to divide by 40 to get 20? And that's where you would come back to the 800. So just be aware that there's different ways to get there, and it all depends on what works best for you. So I'm going to erase that one. And I had another one, because this one has the distributive property in it. And there's a couple ways you can get there, so we're going to talk about it. Now, I've got 12 out in front of the brackets, so 12 times E plus 11, or 12 groups of E plus 11. Now, if I was drawing this out, technically I could draw all that out. It's a lot of pips. I don't think I'd want to do that. Now, you can either distribute that 12 to everything inside, or you can also take a shortcut, because that multiplying by 12, I can actually cancel by dividing by 12 right at the beginning. That cancels out. I'm left with E plus 11, because that's what's inside the brackets, and I can figure this out. So I'm looking at 2, 6, 9, so 96, so 48, 8, so 28. I'm testing myself and my brain with mental math. I feel like I'm going to double check that. Correct. Okay. Ooh. So looking at this now, I'm down to a one-step problem. So I can just subtract 11 from both sides, and bada bing, bada boom, I'm left with the answer, which in this case would be 17. So again, if I substitute this back in, 17 plus 11 is going to be 28, and 28 times 12 would bring me to 336. Now, the other way you could do it is you could, I'll just erase some of this, do it out. Because sometimes this number that's in front of the brackets doesn't evenly go into the other number on the other side. or there's multiple terms over here and it makes it challenging. So what you can do instead is you can distribute that number by multiplying it by everything inside the brackets. So you get 12 groups of E, so 12E, and you get 12 groups of 11, which would be 132. And I'm left with 336 over here because that 12 didn't affect it at that point. I was just expanding this. It didn't actually change the value on this side. You've still got the exact same amount. It's just without the brackets. So I've distributed the 12 to everything inside the brackets. So at this point, I'm a two-step problem. I need to cancel that adding 132 by subtracting it. One thing I will point out too, if you haven't noticed, I've been trying to write my equal signs straight underneath each other because I find that helps me maintain which side of the equation I'm dealing with. And also notice, because I know a lot of you have this habit, you try to do the workout on the side, but you have a hard time taking that work that you've done over there and putting it back into the equation. So really, if you can train yourself, this is the more accepted method of doing algebraic equations. So this canceled out. I'm left with 12E. This, when I subtract it, is going to be 204. Should be right. And then I'm going to divide by 12. And then I'm left with, yeah, it's confirming. Got my 17. So again, I still got to the same place, I just did it in a different way. So there's different ways to get there, and some ways are more efficient for different people. And that's the thing that I think is most important, is that you figure out the way that is most efficient for you. Because the way that's traditionally efficient may be something that is very confusing to you, and it may not be efficient at all because you don't understand how to get there. So if you have a different way of getting there that is effective, then it's probably the way that you're going to want to do it. And you're going to strive to learn the other way, but it's not always going to be what you do. Okay, this is one that has a negative in front. So negative 3 times x subtract 9 equals negative 24. So again, there's a relationship that already exists with that 3 and 24 if you know your number facts. So it's actually probably more efficient to divide by the negative 3 right in the beginning. So if I do that, I'm going to divide by negative 3 here. That cancels this. I'm left with x subtract 9 equals a positive 8. Then I've got to cancel subtract 9 by adding 9, and I'm left with 17 and x. So the thing is, again, if I have 17 and I subtract 9, I'm left with 8. 8 times negative 3 is going to give me negative 24. So that works out. Now, if you are not someone that's good with recognizing your number facts, and you want to distribute this, negative 3 times x is negative 3x. Negative 3 times negative 9 is a positive 27. So keep in mind, a negative times a negative gives you a positive. I'm left with negative 24 over here. So first things first, I've got to deal with that plus 27. So I've got to subtract 27. Now, one thing some people do too that helps is they draw a straight line down where the equal sign should be, just to show the division. That might be something that works for you. So this is going to equal negative 51. Then I'm going to divide this by negative 3 on both sides, and boom, I'm left with 17, and it's a positive 17, just like we got before. So again, different way, but I got there. Now, can I erase this, I think? Yes. I feel like at least with the video, you guys can pause, so it's not like when we're in person and it's all messed up. So x plus 4 divided by 6. So, let's see. We're going to go like that. So, this one is where that Sam Deb gets a little messed up, because your instinct is to get rid of that plus 4 first, but you've actually got to get rid of this, because in reality, the two parts of the ratio or the fraction are actually in brackets. And so you've got to deal with this first. So the opposite of dividing by 6, I'm just going to take these back out, is you're going to multiply by 6 on both sides. Those are going to cancel out because they equal 1. I'm left with x plus 4, and this is 12. Then I'm going to subtract 4, and boom, they cancel, and I'm left with 8. So if I go back, 8 plus 4 is 12. 12 divided by 6 gives me my 2. I would say that covers all of the questions you had earlier. If it didn't cover something and there's still questions you have, let me know in the comments so that way I can do another little video with more to it. But for right now, I feel like that covers two-step problems. I'm going to do a third video in a little while, but what I'm going to do is I'm going to do some more complicated like three-step and multi-step problems. So, thanks for watching. Hopefully you got something out of it, and we'll talk to you soon. Bye.